Within a switched internetwork, VLANs provide segmentation and organizational flexibility. VLANs provide a way to group devices within a LAN. A group of devices within a VLAN communicates as if they were attached to the same wire. A VLAN creates a logical broadcast domain that can span multiple physical LAN segments. VLANs improve network performance by separating large broadcast domains into smaller ones. If a device in one VLAN sends a broadcast Ethernet frame, all devices in the VLAN receive the frame, but devices in other VLANs do not. There are a number of distinct types of VLANs used in modern networks. Some VLAN types are defined by the traffic classes. Other types of VLANs are defined by the specific function that they serve. Data VLAN is configured to carry user-generated traffic. Default VLAN. All switch ports become a part of the default VLAN after the initial boot up of the switch loading the default configuration. This allows any device connected to any switch port to communicate with other devices on other switch ports. The default VLAN for Cisco switches is VLAN 1. A native VLAN is assigned to a trunk port. Trunk ports are the links between switches that support the transmission of traffic associated with more than one VLAN. Native VLANs are defined in IEEE 802.1q specification to maintain backward compatibility with untagged traffic, common to legacy LAN scenarios. A native VLAN serves as a common identifier on opposite ends of a trunk link. A management VLAN is any VLAN configured to access the management capabilities of a switch. VLAN 1 is the management VLAN by default. A management VLAN is any VLAN configured to access the management capabilities of a switch. VLAN 1 is the management VLAN by default. To create the management VLAN, the switch virtual interface (SVI) of that VLAN is assigned an IP address and subnet mask, allowing the switch to be managed by HTTP, Telnet, SSH, or SNMP. A separate VLAN is needed to support voice over IP. This traffic requires a short bandwidth to ensure voice quality, transmission priority over other types of network traffic, availability to be routed around congested areas on the network, delay of less than 1.5 milliseconds across the network. VLANs will not be very useful without VLAN trunks. VLAN trunks allow all VLAN traffic to propagate between switches, so that devices which are in the same VLAN but connected to different switches can communicate without the intervention of a router. A VLAN trunk or trunk is a point-to-point link between two network devices that carry more than one VLAN. A VLAN trunk extends VLANs across an entire network. A trunk does not belong to a specific VLAN. Rather, it's a conduct for multiple VLANs between switches and routers. Catalyst 2960 series switches are layer 2 devices. They use the Ethernet frame header information to forward packets. They don't have routing tables. The standard Ethernet frame header does not contain information about the VLAN to which the frame belongs. Thus, when Ethernet frames are placed on a trunk, information about the VLAN to which they belong must be added. This process is called tagging. It's accomplished by using the IEEE 802.1q header. This standard header includes a 4-byte tag inserted within the original Ethernet frame header, specifying the VLAN to which the frame belongs.
Okay, now we will show you how to create and configure different VLANs within a network. And to do this, we will be using this sample topology that consists of 3 switches and 6 PCs. Take in consideration that basic configuration of the network should already be done, like host names and links between the different interfaces of every switch, and the IP addresses of each PC should already be set up so that we can continue to create different VLANs. For this example, we will be creating 3 VLANs. The first VLAN will contain these 2 PCs, PC1 and PC4. The second VLAN will contain PC2 and PC5, and the third VLAN will contain PC3 and PC6. So to create and configure different VLANs within a network, we need to create every one of them in each one of the switches or network devices that we are going to be using. It's important to know that every switch has the VLAN range. In a normal ranged VLAN has a range of 1 to 1005 VLANs. If we wanted an extended range, it could be done with a range from 1005 to 4096 VLANs. But for this example, we will be using a normal ranged VLAN. So as we can see, switch 2 has no VLANs configured to it except for the default VLAN. This default VLAN is normally set to VLAN 1 and is used as a native VLAN also. It is a common practice to configure an extra VLAN as a native VLAN. So the first thing we need to do is to create all the VLANs that we desire in the switch. To do this, we have to enter the configure terminal mode, and from here we have to type the command VLAN and the number of VLAN we want to create. In my case, the first VLAN will be VLAN. I will assign it to VLAN 10. Here we can select a name for the VLAN. In my case, it will be named faculty. I'm sorry, we have to type the command name faculty. So VLAN 10 is now named faculty. After that, we proceed to configure the other two VLANs. This will be named student, and the third VLAN will be named guest. And I'm going to create an extra VLAN that will function later on as a native VLAN, but I won't name this VLAN. So now we can verify our VLANs that we just created with show VLAN brief command. And here we have VLAN 10, VLAN 20, and VLAN 30 and VLAN 99 created. So now we have to do this for all the switches. Once we have all the VLANs created in every one of the switches, what we will proceed to do is to assign the ports of the switches to the VLAN they correspond. For example, port Fast Ethernet 0/11 will belong to VLAN 10. Fast Ethernet 0/18 will belong to VLAN 20, and Fast Ethernet 0/6 will belong to VLAN 30. The same way for the switch 3, and after configuring the ports to their belonging VLANs, we will continue to configure trunk ports, but I will explain what a trunk port is later on. To assign the ports to their corresponding VLAN, what we need to do is first of all make sure that the VLANs do not have unwanted ports. So after that, we need to type in the command interface Fast Ethernet and the number of the port we want to configure, and then type the command switch port mode access. After that, type in the command switch port access VLAN and the number of VLAN that this port will belong to. In this case is VLAN 10. So now we can verify that in fact VLAN 10 now has the port Fast Ethernet 011 assigned to it. So now we do the same for the other ports that we want to configure. Show switch port mode access, switch port access VLAN 20, exit, we verify, and we have that VLAN 20 now has this port. We do the same for the third port and the third VLAN, and after completing this switch we do the same for the third switch. Once we have all the VLANs configured with their respective ports in each one of the switches, what we need to do is configure a native VLAN and the trunk ports in order for it to function correctly. A trunk port is a link, a layer 2 link between two network devices. So in these ports of that connect switch 1, switch 2, and switch 1 and switch 3 will function as trunk ports. Note that switch 2, switch 1, and switch 3 are connected through the gigabit Ethernet ports. So to configure those ports as trunk ports, what we need to do is access them with the interface gigabit Ethernet 0/1 in case of switch 2, and we need to type in the command switch port mode trunk. These two lines will indicate that the gigabit Ethernet 0/1 port now functions as a trunk port. So now we have to indicate that VLAN 99 will function as a native VLAN. To do this, we enter the command switch port trunk native VLAN 99. And after this, we need to specify the VLANs that will be able to communicate using the trunk ports. To do this, we enter the command switch port trunk allowed and a list of VLANs that we want to intercommunicate. 10, in this case 10, 20, and 30. I'm sorry. Before the list of VLANs, we have to specify that these will be VLANs. So the command is switch port trunk allowed VLAN 10, 20, 30. And finally, to verify that the port is actually functioning as a trunk port, we need to type in the command show interfaces gigabit 01 switch port, and here we have that it is functioning as a trunk port. So now what we have to do is configure the trunk ports for switch 1 and switch 3. One of the most common mistakes while creating and configuring VLANs within a network are trunking mismatches. It is extremely important that the trunking protocol in this switch and the trunking protocol in this switch are the same and are compatible between them. Otherwise, trunking won't be achievable and communication will be lost. So these were the basic configuration commands to create and configure VLANs within a network. I recommend that you read the Cisco curriculum in order to see how to delete VLANs, how to reassign ports to different VLANs, and other configuration commands that weren't covered in this exercise or in this example. Finally, I would like to finish by commenting that in this example, VLANs are not able to communicate between one another. This was not mentioned in the curriculum, but in order to communicate one VLAN with another, we have to assign an IP address to each VLAN. For example, if I try to ping from PC1 to PC4 to PC5, I won't be able to do it. For example, if I try to ping from PC1 to PC5, I won't be able to do it. This is because they do not belong to the same VLAN. However, if I ping from PC1 to PC4, I can do this, and the packet is sent correctly. In the same form, if I try to send a broadcast, the packet won't be sent because there is no communication between VLANs. To correct this, an IP address must be assigned to every one of the VLANs, and that way routing can be done between VLANs.
Although VLAN architecture simplify network maintenance and improve performance, it also opened the door to abuse. It is important to understand the general methodology behind these attacks and the primary approaches to mitigate them. VLAN hopping enables traffic from one VLAN to be seen by another VLAN. Switch spoofing is a type of VLAN hopping that works by taking advantage of an incorrectly configured trunk port. In a basic switch spoofing attack, the attacker takes advantage of that the default configuration of the switch port is dynamic auto. The network attacker configures a system to spoof itself as a switch. This spoofing requires that the network attacker be capable of emulating 802.1q and DTP messages by tricking a switch into thinking that another switch is attempting to form a trunk. An attacker can gain access to all the VLANs allowed on that trunk port. The best way to prevent a basic switch spoofing attack is to turn off trunking on all ports, except the ones that specifically require trunking. On the required trunking port, disable DTP and manually enable trunking. Another type of VLAN attack is a double-tagging VLAN hopping attack. This type of attack takes advantage of the way that hardware on most switches operates. Most switches performs only one level of 82.1q, the encapsulation, which allows an attacker to embed a hidden tag inside the frame. This tag allows the frames to be forwarded to a VLAN that the original tag did not specify. An important characteristic of the double encapsulate VLAN hopping attack is that it works even if trunk ports are disabled, because a host typically sends a frame or a segment that is not a trunk. Some applications require that no traffic be forwarded at layer 2 between ports on the same switch, so that the neighbors do not see the traffic generated by another neighbor. Benefits of using VLANs. User productivity and network adaptability are important for business growth and success. VLANs make it easier to design a network to support the goals of an organization. Security. Groups that have sensitive data are separated from the rest of the network, decreasing the chances of confidential information breaches. Cost reduction. Cost saving result from reduced need for expensive network upgrades and more efficient use of existing bandwidth uplinks. Simpler project and application management. VLANs aggregate users and network devices to support business or geographic requirements. Having separate functions make managing a project or working with the application easier. Better performance. Dividing flat layer 2 networks into multiple logical work reduces unnecessary traffic